Hello everyone, welcome back to another episode of Math Unlocked, and I'm your host, Mrs. Rhodes-Grierson. Alright, so today what we're doing, we're still at factorizing, but in today's session we'll look at how do I factorize a four-term expression. Now, I would have expected by now that you'd be able to identify that the expression has four terms because you have been following us. You would have watched how to identify terms, coefficient constants. This is four terms because terms are separated by two operations, either addition or subtraction. So I know that this is my first term. This is separated by addition, so this is my second term. This is separated by addition again, so that's my third term. This is separated by addition again, so that's my fourth term. So we have four terms in this expression, and I want to be able to factorize it. Now, we're going to do a method called grouping, and there's a reason for that. Now, if I was to try to factorize all four terms in one in this expression, you would take note that the factors of x squared would have been 1, x, and x squared. We've gone through this already, but we're repeating it for emphasis. The factors of 3x would have been 1, 3, x, and 3x. The factors of 2x would have been 1, 2, x, and 2x. The factors of 6 would have been 1, 2, 3, and 6. Now, once you're able to identify your factors, in factorizing, you want to find the highest common factor. Highest, common, and factor. Now, we already identified the factors, so now we need to look at what's the highest common one. If you look amongst all four terms, we look first at our numerical factor. This has only 1. So that means that if I should look throughout, 1 would have been the only thing that this one have in common with all other ones. Now, I cannot have an expression and factorize the entire expression by 1, because if I factor out 1, it means that anything 1 multiplied by any other quantity will give you back the same thing. So it means that the expression itself would have been written again, and it would have not looked any different from what is there. So when we factorize an entire expression, we want the common factor not to be 1. Right? The highest common factor, we're not looking for a 1 for the entire expression. It can be a factor of piece of the expression, but not the entire expression. Right? So what is happening here is that we'll notice that 1 is the highest common numerical factor all throughout. And if I should take x, x is common here, 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 but it's not over here. So that means if I should try to factorize the entire expression together, I'm having limitations. So I would need to see how else could I factorize it. Now, when you have four terms in an expression, you want to do what we call grouping. We're going to be grouping the first two terms here because those two terms have a common factor. X is common here. And then we want to group the second two terms because they also have a common factor. Apart from, they have a common factor as well. And I can notice that this has 2 in common and this also has 2 in common. So I'm going to be splitting the expression into two parts. The first two terms, I'm going to factorize them together. The second two terms, I'm going to factorize them together. Notice where I put the split here because I'm taking the first two. The third term was separated from the second term by addition. So this sign goes with that term. So positive 2x goes there. Now I'm factorizing these two, and I would have known how to factorize expressions already. So here what you're introduced to that's new is the concept of grouping them. So you're grouping, you take the first two pair, you take the second two pair, and you're going to factorize by grouping because each pair does have a common factor, right? So now, within this two pair, the highest common factor would have been x. So I notice that it has 1 and x in common. So I take 1x, bearing in mind that 1x is still just writing x because 1 unit of x is still an x by itself. I can write 1x to make it clear that it's 1 unit of x. With or without the 1, it doesn't change that it's just 1 unit of x, right? Now, 1x will multiply a quantity sorry about that disturbance. 1x will be multiplying a quantity, and there are two terms that we're factorizing, so I'm holding the place of two things here to ensure that I do not leave anything out when I do my factorization. So there are two terms. I should account for two terms. Now 1x is multiplying what to give me x squared? This takes us back to the laws of indices, that if there's an x to the power 1 out here, if I want x to the power of 2, if I'm multiplying, it means that when we multiply, we would add the powers to know what is the index on it. So since it's a power of 2, it means that there must be a power of 1 inside and a power of 1 outside, such that when we multiply, it would have been 1 plus 1 that gives us 2. Now when we have powers of 1, just like when we have coefficients of 1, we don't need to write them, because with or without the 1, it's an indication that it's actually a 1 that is there. So x times x, with an invisible 1 here that we didn't write, would have been x squared, right? So let me just leave those in place for now. Now 1x is multiplying what to give me 3? Positive 3x, that is. This must be positive, such that when I multiply 1x times a 3, it will give me back my positive 3x. And we're also always ensuring that what we multiply out is getting back our original expression, otherwise we would have done something wrong. Alright, I've factorized my first two terms. I'm coming over here. I'm going to factorize these two terms as well. Remember, terms are separated by addition or subtraction. So since this is a new term that I'm factoring, I need to put either addition or subtraction here. So, and this is addition, so I'm going to go with the addition. I'm looking at what is the common factor. That was a common factor of 2. Now I'm holding the position of the two terms because these were two terms being factorized, so I must have two terms here. 2 is multiplying what to give me 2x? 2 would multiply x to give me a 2x. 2 is multiplying what to give me a positive 6. This must be positive as well. A positive times a positive gives me back a positive. So this is positive 3. I am almost there, but I'm not complete because I have factorized by grouping, and I noticed that after factorizing it, the bracket here and the bracket here is the same thing, which means that this term, which is now one term because it's being multiplied, the entire bracket is being multiplied by x. And if you watched the video before when we were factorizing expressions like this, you'd notice that the entire expression here is being multiplied by x, and this entire expression is being multiplied by 2, which means that both terms here have a common factor of x plus 3. So the entire expression of x plus 3 is a common factor of the first term and the second term. So we're going to factorize by the expression, and when we factorize, we use the common factor to multiply. Therefore, there I open another bracket without anything in between to imply multiplication. What is it multiplying? This expression must multiply x to give me back the entire expression there. So one term accounted for. My second term, addition of plus 2, because this term here was being multiplied by a 2. So I'm now complete with the factorization, because I would have now factorized the 4 terms to get 2, and factorized again. And the reason for factorizing again is because these two terms had a common factor. Hence, I could factorize once more to get my complete factorization. So what is it that you need to recall? When you have a 4-term expressions, in most cases, you'll be doing 2 stages of factorization. One, by grouping terms that have something in common, factorizing once. The second step is to factorize by the common bracket, and then you are complete. So don't forget to like, subscribe, and share these videos for more to come. See you next time.